Methods of data collection: recording 3D and 2D imaging. 3D and 2D imaging are used to record sporting activities. 2D images are flat and they have two dimensions, which might be length and breadth, or length and height. A 3D image is one that provides more depth and has three dimensions such as length, breadth, and height. The benefits of 2D imaging when recording at college are that it's quicker to record images, it's faster, and it's easier to extract the relevant data from the images. It doesn't require more sophisticated software, and it doesn't require more advanced technical knowledge to understand how to process and interpret them. Recording digital images. Digital images are images that are captured using digital camera or recorder. The pictures are made up of a series of square pixels and are recorded as data instead of on film. The benefits of using these images and digital equipment as opposed to traditional film is that you can instantly see the image captured. They can be manipulated to show different styles, and they can be shared online, and they can be stored electronically on a computer. Recording shutter speed and frame set. Sporting images tend to be dynamic and fast-paced, and so to ensure the action has been captured, a digital camera or video should record a fast frame rate and shutter speed. The frame set is how many frames are created every second, and the shutter speed is how long each frame is exposed for. As a rule of thumb, the shutter rate should be approximately double the frames per second. Measuring horizontal scaling. Before filming and recording images, the field of view needs to be scaled. The field of view is the area that will be filmed that contains the sporting action. Before filming, there will be the need to record a tester holding a 1 meter rule in the field of view to scale the image. Once scaled, it is important not to move the camera or use manual focus, as the scaling will be incorrect and could lead to invalid data. Scaling allows measurement of playback, which can then be converted into real-life measurements. For example, if looking at the stride length of a long jumper, the 1 meter real life might be equal to 2 centimeters on screen. If the stride length was 2.5 centimeters on screen, this would equal 1.5 meters in real life. Measuring vertical reference. The principle of the vertical axis is the same as the horizontal, and shot would have been set up in the same way. This type of shot would be appropriate for an athlete performing a high jump or basketball leaping for a ball or dunking a net. Measuring perspective error. Perspective error is where someone or something can look a different size to what it actually is. For example, something can appear to be larger when it is recorded close up, and the same object can appear much smaller from further away. If a camera is wrongly positioned when filming, it will produce invalid data and the recording will be worthless. To avoid this, any dynamic action should be recorded, and the field of view and only a sample of performance should be taken. As seen on the screen here, there are different pictures of a measuring device used called force plates. A force plate is an instrument that's used that detects and measures the forces that are produced during physical exercise. In our experiment, we used them to measure the force of jumps. Shown here are light gates, which are sensors to measure timing experiments. For us, it was for measuring sprints. The light gate has an infrared transmitter and receiver that will detect an object passing through the gate. Here are briefly the results from our experiment that will be further analysed in 6.4. As you can see, for the 20-metre sprint time result, the better player travelled a larger distance in a shorter amount of time than the worse player. For velocity, the better player kept a lower velocity in the same amount of time than the worst player. For acceleration, both of the players showed very similar acceleration over time. And shown here is a comparison of 3/4 sprint times with which shows that our performer did it in the longest amount of times, which was in seconds, around 4 seconds. The group average was a bit lower than the performer, doing it in a shorter time, around 3, 4, 5 seconds, and the elite athlete did it around 2:80, and then the better player had a really good score of 2:50, which showed that they did it in the quickest amount of time and therefore possibly has the most efficient sprinting technique. And finally, here's a comparison of peak powers. So our performer used exerted the lowest amount of power compared to the NBA elite athlete, which exerted a huge amount, around 8,050, which probably helped with their sprinting times, and the better performer had a good power output, around 500.